Weather shapes our world. It dictates our clothes, our activities, even our moods. Understanding weather is about more than just knowing if we need an umbrella. It's about appreciating the powerful forces that govern our planet. From the gentlest breeze to the fiercest hurricane, weather is a constant reminder of nature's awe-inspiring power. It's a dance of air and water, driven by the sun's energy and shaped by our planet's rotation. By understanding weather patterns, we can anticipate changes in our environment. This knowledge allows us to prepare for extreme events, conserve resources, and plan for the future. We live at the bottom of an ocean of air, the atmosphere. This vast invisible ocean is essential to life on Earth, providing the air we breathe and protecting us from the harsh conditions of space. This invisible layer surrounding Earth is the stage where weather unfolds. From the gentle breeze to the most violent storms, all weather phenomena occur within this thin veil of gases. The atmosphere is made up of different gases, mainly nitrogen and oxygen, which provide the air we breathe. Nitrogen makes up about 78% of the atmosphere, while oxygen accounts for around 21%. The remaining 1% consists of other gases like argon, carbon dioxide, and trace amounts of others. Air pressure is a key player in the weather drama. It is the force exerted by the weight of air above us, and it influences everything from wind patterns to precipitation. It's the weight of the atmosphere pressing down on us. This pressure decreases with altitude, which is why mountain climbers often need supplemental oxygen. Warm air is lighter, creating low pressure. When the sun heats the ground, the air above it warms up, becomes less dense, and rises, leading to areas of low pressure. Cold air is denser, creating high pressure. In contrast, cold air sinks because it is heavier, leading to areas of high pressure. Air naturally moves from areas of high pressure to areas of low pressure, creating wind. This movement is a fundamental aspect of our weather systems. The greater the difference in pressure between two areas, the stronger the wind blows. This is why we experience strong winds during storms, as the pressure differences are more pronounced. This constant movement of air is what drives our weather systems, transporting heat and moisture across the globe. These systems are responsible for the diverse climates and weather patterns we experience, from tropical rainforests to arid deserts. Understanding the dynamics of the atmosphere helps meteorologists predict weather and prepare us for the changes it brings. Water, in its various forms, plays a starring role in the weather drama. The sun's energy powers a continuous cycle of evaporation, condensation, and precipitation. Oceans, lakes, and rivers constantly lose water to the atmosphere through evaporation. This invisible water vapor rises, cools, and condenses into tiny droplets, forming clouds. When these droplets become heavy enough, they fall back to Earth as precipitation, rain, snow, sleet, or hail. This water then flows back into rivers, lakes, and oceans, completing the cycle. High above us, invisible rivers of air snake their way across the globe. These rivers, though unseen by the naked eye, are powerful forces that shape our weather and climate. They are constantly in motion, flowing and shifting, creating patterns that affect everything from daily weather to long-term climate trends. These are the jet streams, fast-flowing currents of air that circle the planet at high altitudes. Jet streams are typically found in the upper levels of the atmosphere, around 6 to 9 miles above the Earth's surface. They can reach speeds of over 200 miles per hour, making them some of the fastest-moving air currents on the planet. They form at the boundaries of warm and cold air masses. This is where the temperature difference creates a pressure gradient, which in turn generates these powerful winds. The most well-known jet streams are the polar jet streams and the subtropical jet streams, each playing a unique role in our weather systems. Jet streams play a crucial role in steering weather systems. They act like highways in the sky, guiding storms and weather fronts across the globe. When a jet stream dips or rises, it can bring cold air down from the poles or warm air up from the tropics, significantly impacting the weather we experience on the ground. They can push storms across continents, bringing rain or snow to vast areas. For instance, a strong jet stream can carry a storm system from the Pacific Ocean all the way to the east coast of the United States, affecting millions of people along the way. The position and strength of jet streams can influence the severity of weather events. A shift in the jet stream can mean the difference between a mild winter and a severe one, or between a dry season and a season of heavy rainfall. These shifts are influenced by various factors including the Earth's rotation, the distribution of land and sea, and even human activities. A strong jet stream can intensify a storm, while a weak or meandering jet stream can lead to prolonged periods of unusual weather. For example, a strong jet stream can enhance the development of a hurricane, making it more powerful and destructive. Conversely, a weak jet stream can result in stagnant weather patterns, leading to extended periods of drought or excessive rainfall. Understanding jet streams is crucial for meteorologists as they predict weather patterns and prepare for extreme weather events. Section 5. The Pulse of the Ocean. The ocean is a vast and dynamic entity constantly in motion and teeming with life. Its surface, ever-changing, reflects the pulse of our planet. Oceans cover over 70% of Earth's surface, acting as giant heat reservoirs. They absorb and store solar energy, playing a crucial role in regulating the Earth's climate. The vast expanse of water is not just a passive entity, it is a dynamic force that shapes weather patterns and influences global temperatures. Ocean currents, like massive conveyor belts, circulate warm and cold water around the globe, influencing climate patterns. These currents are driven by wind, water density differences, and the Earth's rotation. They transport heat from the equator towards the poles and bring cold water from the polar regions back towards the equator, creating a balanced climate system. Warm currents like the Gulf Stream bring heat from the tropics towards the poles, moderating temperatures in coastal regions. This warm water current is responsible for the mild climate experienced in Western Europe, making it significantly warmer than other regions at similar latitudes. Cold currents like the California current have the opposite effect, keeping coastal areas cooler and often drier. These currents bring nutrient-rich waters from the deep ocean to the surface, supporting a diverse marine ecosystem and influencing the weather patterns along the coast. The interaction between the atmosphere, ocean currents, and land masses creates complex and interconnected weather patterns across the planet. This intricate dance between the ocean and the atmosphere drives phenomena such as El Niño and La Niña, which have far-reaching impacts on global weather and climate. Understanding these interactions is key to predicting long-term climate trends. Scientists use advanced models and simulations to study the ocean's behavior and its impact on the climate. By analyzing data from satellites, buoys, and research vessels, they can forecast weather patterns and predict changes in the climate, helping us prepare for the future. Section 6. Predicting the unpredictable. For centuries, predicting the weather was more art than science. People relied on observation, folklore, and intuition to anticipate changes in the skies. Today, weather forecasting has become increasingly scientific and accurate, thanks to advancements in technology and our understanding of atmospheric processes. We now have a global network of instruments constantly monitoring the atmosphere and oceans. These instruments, combined with powerful computer models, allow meteorologists to track weather systems and make increasingly accurate predictions about future weather conditions. Section 7. Eyes in the Sky. Satellites orbiting Earth provide a bird's-eye view of weather patterns. These sophisticated instruments constantly monitor cloud cover, temperature, wind speed, and precipitation. Data from satellites is relayed back to Earth in real time, providing meteorologists with a continuous stream of information about the state of the atmosphere. This global perspective allows us to track the movement of storms, predict their intensity, and issue timely warnings to vulnerable populations. Section 8. The Power of Prediction. Accurate weather forecasting has become an essential tool for modern life. It allows us to make informed decisions about our daily activities, from planning a picnic to preparing for a hurricane. Farmers rely on weather forecasts to make crucial decisions about planting and harvesting crops. Airlines use forecasts to plan safe and efficient flight paths. Emergency services depend on accurate predictions to prepare for and respond to natural disasters. Accurate weather information saves lives, protects property, and ensures the smooth functioning of our increasingly interconnected world. Section 9. Living with the weather. Weather is a powerful force, but it is also a source of wonder and beauty. By understanding weather patterns, we can not only prepare for its impacts but also appreciate its intricate dance across our planet. As technology advances, our ability to predict and adapt to weather will continue to improve. However, it's essential to remember that we are part of a complex and interconnected system. By respecting the power of nature and making informed decisions based on scientific understanding, we can live in greater harmony with the ever-changing skies above us.